Hello, just want to spend some time in this video going over an oblique collisions question in mechanics, in further mechanics. It's always been on further mechanics. This one's from an old AQA question, not that old, but it's the old syllabus. And I've just chosen it because it's a reasonably long question. It's just a case of thrashing it out, and it's relatively standard. Not to say it's easy, but there's nothing really particularly nasty about it. I'm going to use the diagram above for ease of space, so I'm going to just mark in the components here. Our approach is always with collisions, with oblique collisions, is to split into components parallel and perpendicular to the line of centres. Okay. So looking at these, this component here is 3u sine theta, and this is 3u cos theta, because they're going towards each other. This one's going with speed 3u, and this one's going with speed u at the same angle, but they're hitting each other at a kind of along a different line. That makes sense. And this one similarly is u cos theta and u sine theta. Okay, and it wants us to find out the angle theta. It tells us some extra information here about the speed of A after the collision being twice the speed of B, but that's going to be the speed of A. This is before. Let's do the after one in below. That's going to be That's going to be the whole speed of A. That's going to be the combined speed, not just in any particular direction. So we'll use that at the end. I suspect that's going to be coming into the end. So that's the one thing that this makes this kind of sets this question out from other questions. That's the one particular thing about this question. So let's call this the final speed along the line of centres of VB, the component along the line of centres, and this being the final of VA. Now, of course, this will be unchanged from here. So that's u sine theta. And this one will be unchanged from here. So that's 3u sine theta. Okay, so we're going to apply momentum. So conservation of linear momentum first. So before, they're going in the opposite directions. This one's got m, so that's 3u cos theta times m, minus, because it's going in the opposite direction here, 2m times by u cos theta. And now we can just talk about the combined of these. So this has got, VA has got mass 1, so that's 1m times VA, and plus 2m times VB. Okay, so obviously m cancels. So let's cancel out the m and tidy up a bit. That gives us that VA plus 2VB equals to, here we've got 3u and here we've got u, so that equals to u cos theta. Okay, so that's my conservation of linear momentum part. Just make myself a little bit more space here. So then Newton's law of restitution. Right, notice that these two are coming towards each other, the verticals, so that's they're kind of approaching each other. And Newton's law of restitution says speed of separation, which is VB minus VA, over speed of approach, which will be 3u cos theta plus cos theta. Okay. equals to, and that's going to be equal to, and it's given us the coefficient of restitution as 1/8. So that comes to VB minus VA equals to a half U cos theta. Okay, so now I can, I don't know what's happened there. So now I can add these two. So I'm going to add. So we have 3VB is equal to, add in the 3VB is equal to 3/2 U cos theta. So that gives me VB is equal to half U cos theta. Now if VB is equal to half U cos theta, then VA has to be equal to 0. So we found out VB and VA. So now we're going to bring in this one thing that's going to enable us to work out the value theta in this question. That the speed of A is twice speed of B, but be careful, we mean the combined, we mean obviously the overall speed, not any particular component in a direction. So we can say that these two combined are, these two combined are twice as much as these two combined. Now if this were linear in a line, that would not normally be possible, but of course it is here because it started off at higher speed. So this speed of this is twice as much as the speed of this. Well, remember VA is equal to 0. So we've got so let's write out what we're using. Speed of A equals 2 times speed of B. So the speed of A is, just because this bit is 0 here, it's just going to be equal to 9, well, let's just write it out, 3U sine theta squared. But that's going to be, oh no, it's just 3U sine theta, of course. But the speed of B is going to be the square root of the sum of the squares of these components. So that's U sine theta squared plus VB squared, which is half U cos theta squared. Times by 2. So squaring this out, we get 9U squared sine squared theta is equal to 4 times by U squared sine squared theta plus 1/4 U squared cos squared theta. And obviously we're going to get the U squared cancelling, multiplying out the 4. So we've got 9 sine squared theta equals to 4 sine squared theta plus cos squared theta. So that gives us that, let's just get a bit more space here. Ooh, that's not what we wanted, never mind. Okay, so that gives us that 5 sine squared theta is equal to cos squared theta. So that gives us tan squared theta equals to 1/5. Tan theta equals to 1 over the square root of 5. So we can work out that angle. Inverse tan of 1 divided by the square root of 5, 24.1 degrees. Okay, so nice, I wouldn't say easy, but yeah, relatively routine at this level, 12 marks in an oblique collisions type question. Okay, hope you found that helpful. Bye.